In the first part, we explored what causes anemia. Now, let's zoom in and take a closer look at what's happening under the microscope as red blood cells adapt to the challenges they face. In iron deficiency, there simply isn't enough iron in the bone marrow to produce hemoglobin. Red blood cells are born in the bone marrow from mother cells called erythroblasts. These cells are supposed to divide and grow, accumulating hemoglobin along the way to mature into functional red blood cells. But here's the catch: hemoglobin production depends on iron. When there's not enough, as in iron deficiency anemia, hemoglobin production slows down, delaying the maturation of these cells. But the body doesn't stop there. It senses a huge demand for oxygen-carrying red blood cells and pushes these precursor cells to divide rapidly to meet that demand. The result, with each division, the new cells get smaller. Plus, without enough hemoglobin, they look paler, since hemoglobin gives red blood cells their color. So, when these red blood cells are released into the bloodstream, they're fewer in number, smaller in size, paler, and have all sorts of irregular shapes due to their abnormal development. In iron deficiency anemia, these red blood cells are doing their best under tough conditions, but the lack of iron leaves them struggling to perform their critical role of carrying oxygen. Next, let's look at thalassemia, an inherited condition passed down from parents to children through genes. In this disorder, the body produces defective hemoglobin chains, leading to a shortage of functional hemoglobin. This shortage results in smaller, paler red blood cells. To accommodate the uneven distribution of hemoglobin, the red blood cell membrane distorts, creating a target-like shape. Now, in sickle cell disease, an inherited issue with the hemoglobin structure causes red blood cells to become, as you might have guessed, sickle-shaped. These abnormal crescent-shaped cells can't carry oxygen properly, and they tend to get stuck in blood vessels, causing further complications. In cases of hemolysis, red blood cells break down prematurely. This can result in fragmented cells or bite cells, which are the result of the spleen removing damaged parts of the cells. So, how do you know if you have anemia? Look out for common signs, such as pale skin, shortness of breath after light activity, or feeling tired more easily than usual. A simple blood test can help diagnose anemia by checking your hemoglobin levels, as well as the number and size of your red blood cells. Treating anemia depends on the cause. For iron deficiency anemia, iron supplements and dietary changes, such as eating iron-rich foods like leafy greens, meat, and beans, can help. The good news is that most cases of anemia are treatable. By understanding the causes and how anemia affects your body at the microscopic level, we can take steps to manage, treat, and even prevent it. Thanks for joining us on this journey through the fascinating world of red blood cell diseases in microscopy. If you found this video insightful, don't forget to like, share, and subscribe to Pathosight for more eye-opening looks into the microscopic wonders of the body.